Hi, this video is a video on graph conversion. In this case, we're going to talk about the conversion between vector graphs to scalar graph. So what I mean by vector graph to scalar graph is these two main common conversion that we face in the study of kinematics. The first one is between displacement and to distance time graph, displacement time graph to distance time graph. The second one is convert from velocity time graph to speed time graph. So let's look at conversion between displacement time graph to distance time graph first. Now, some of the key points you need to take note before we dive into this part is that number one, displacement is the position of the object from the starting point. So displacement can be either positive or negative depending on its position from the point. Alright. Now for distance, on the other hand, it is actually the total length traveled, and it is regardless of the direction. So in other words, it is always positive as it is the total length traveled. So whether the displacement is moving forward in the positive direction or moving backwards in the negative direction, alright, to distance, both positive motion and negative motion is always positive and is always adding up. Okay, so this is something you need to take note. So let's start with a very simple graph. For example, such a graph where the displacement is the same throughout the time. So from this kind of graph, we know that the displacement did not change, and the object is at a certain displacement from its rest position, which is the origin here. Now from this case, we know that the displacement remain at the same point, so it is actually at rest. Alright, when it's at rest, okay, the distance move is 0 meters. So if the distance move is 0 meters, do we draw it at this point or do we draw it elsewhere? The answer is we have to draw it the same way but along the time axis. Okay, the reason being it has not moved at all. So because of that, the distance traveled is 0. Okay. Now let's look at the second case. What if the displacement is increasing on a constant rate? So we can call this constant positive velocity. Alright. We can see that the displacement has increased in a certain rate. So this increase will also cause a corresponding increase in the distance time graph. So we will expect that the graph is identical. Okay. So let's look at more complicated examples. What if you have a case where there is the displacement is constant first, then increase? Okay, you may want to pause the video before we show you the answer. Okay, I hope that you have already figured out the answer. We're going to review it to you. So before I review, just one key note is that distance only increase when displacement increase, alright, or decrease. Sorry, I think I should add or decrease. Alright. So what do I mean by this? When this displacement has no change, the distance has no change at all. But when the displacement increases, the distance also increases correspondingly. So this is the distance time graph. Now how about the opposite? If we have displacement decreasing, using the same term here, alright, so this displacement decrease, the distance increase. So displacement increase, distance will increase when displacement increase or decrease. Displacement increase or decrease, the distance will still increase, alright, because regardless of whether it's increase or decrease, the distance always increases. So the answer is it will be a flip of the gradient to become positive. Okay, so let's move on to more complicated examples. Now what about this one? I hope you can pause the video now and try to find out the answer yourself first. Okay, so I hope you have already written down your answer. So the answer is number one. Let's just examine this. There is an increase here, alright, followed by constant, then followed by a decrease. So when there's an increase, the distance will increase. Here will be constant, and then there will be a second increase. So we're going to get a graph of this shape. Okay, now how about this kind of graph? Let's examine again. There's a decrease here, followed by constant, then followed by an increase. So here a decrease is still an increase, and then a constant is a constant, and then an increase is an increase. So you're going to get something like that. Okay, increase followed by a second increase. Okay, so distance only adds up whether displacement is increasing or decreasing. This is what we can sum up. So let's examine this kind of questions using actual values that are given. Alright, for example, this kind of question. Now I want you to pause the video again so that you can try it yourself before we show you the answer. Okay, I hope that you have already done the question. So let's examine this question in more detail. First, there is a decrease here. Okay, the decrease in value is 12 meters. Alright, then after that, there was an increase. Okay, from here to here, which is from 8 to 28, so it's 20 meters. So when there's a decrease, it's still an increase. So the first step is a increase of 12 meters, followed by a constant, then the increase of an additional 20 meters. So the answer is going to be like that. Increase, constant, then increase of another 20 meters. Alright. So let's look at another question. Okay, so this question. Alright, draw the distance time graph. Okay, from this displacement. So again, I hope you can pause the video for a while before I show you the answer. Okay, so I hope you have found the answer already. So the first part again is a decrease of 10 meters, followed by an increase of 18 meters, followed by a decrease of 8 meters. So what we're going to expect is that there will be a increase of 10 meters, followed by 18 meters, followed by 8 meters. So the graph is going to be like that. 10, followed by 18, followed by 8. Alright, the timing will be the same. Okay, hope that this will enlighten you to the drawing of displacement to distance graph. So let's go on to velocity to speed time graph now. Now velocity to speed time graph is a lot easier. The key point is, number one, velocity can be negative or positive, but speed can only be positive. So what do I mean by this? Let's look at some of the graphs. So if let's say the velocity is a horizontal constant velocity at this value, the speed time graph will be exactly the same because both are positive. So the velocity positive, the speed will be positive. If the velocity is increasing but it is positive in the direction of increase, the speed will also be positive and the shape will be identical. So when velocity is positive, the speed time graph will be identical. Now what happens if you have a velocity that is decreasing? Alright, when you have a velocity that is decreasing and is negative, what happens is that the speed time graph will just be a reflection of this graph. While if you have a velocity that's negative, constant, but it's negative value, again the speed time graph is a reflection, so it's become positive. It's just making all the negative value to be positive. Right, so if the velocity is negative, speed is just changing all negative values to positive. So in short, it's actually a reflection on the x-axis. Alright, so if this is the velocity graph, the speed time graph will just be reflected here. It's just an image of the velocity time graph, so it becomes like that. If it's here, then the speed time graph will be here. Right, it's a reflection on the x-axis. So imagine the x-axis like a mirror and it's just reflected up. So let's examine some other questions. How about this? Okay, so you may want to pause the video and try it first. Okay, you got the answer. The answer will be like that. Anything that's positive will remain positive. Anything that's negative becomes positive, reflected up. Second one, this one. Okay, pause the video again. So the answer is like that. So what happened is that anything that's negative here will become positive. So it's just reflected up. Okay, it becomes this way. Okay, so again, if velocity is negative, speed is just changing all negative values to positive. So let's examine one with actual data. So how about this case? So can you pause the video and then just try yourself? Okay, I hope that you have tried it already. So this part will remain the same, but this part will be reflected up. Okay, so you're going to get something like that. You will just go down, and then this value here will be the same as this value here. Then you will reflect up to 18. Okay, so let's try last one before we end this lesson. Again, it's a very simple reflection. All this will go up. Okay, so you want to try it first before I show you the answer. Okay, so the answer is this. So you'll go 12, come down, then you go up to 10, then go down again, and then go up to 20. Okay, so that is the end of this video. I hope that this video has enlightened you to the difference between the conversion of vector to scalar. Okay, that's all, and have a nice day.